Hello everybody. In this lesson I will discuss grade 12 probability, more specifically another 5 questions from previous exam papers. Question 1. Ping pong balls are numbered 1 to 12 and placed in a hat. Every time a ball is drawn, it is placed on a rack one next to each other. Question 1. How many different arrangements of the 12 balls are possible? And your answer 12 factorial. And that one you read as 479,001,600. Question 2. Assume that the numbers 8 and 11 must be placed next to each other in any order. In how many different ways can the numbers be arranged? Now, do you agree our answer is 2 factorial, and the 2 factorial, that is the 8 and the 11 that have to be placed next to each other. Times, now where does the 11 factorial comes from? Do you agree there were 12 balls, and now we took away number 8 and number 11. So in fact, there's 10 balls left. But you also have to consider this 2 factorial. That means it was the group where you found the number 8 and 11 ball. So you add that to the remaining balls. And then your answer will be 79,833,600. Question 3. The numbers 2, 5, 6 and 9 are taken from the group of balls. 2-digit numbers must be formed out of these 4 numbers. How many 2-digit numbers can be formed? Now, this means, in fact, it's as if you take the 2 and then the second digit can be 5, 6 or 9. There's the 5. The second digit can be 2, 6, 9. There's your 6. The second digit 2, 5, 9. There's the 9 and then the second digit 2, 5 or 6. So do you agree there's in fact 12 possibilities? And then therefore your answer 4 times 3 is equal to 12. Question 2. A password consists of 5 different letters of the English alphabet. Each letter may be used only once. How many passwords can be formed if 2.1 all the letters of the alphabet can be used? Now, do you agree the password has to consist of 5 different letters? Now, there's your 5 spaces. And each letter may be used only one. In other words, there's no repetition. Therefore, in the first space, you have a possibility of 26 letters. And then no repetition is allowed. Therefore, in the second space, 25, 24, 23, 22. You times all of that together and your answer 7,893,600. 2.2. The password must start with a D and end with an L. Therefore, it starts with a D and ends with an L. Now, do you agree you only have 24 letters left? And then no repetition times 23 times 22. And your answer 12,144. Question 3. 7 cars of different manufacturers, of which 3 silver, are to be parked in a straight line. 3.1. In how many different ways can all the cars be parked? Do you agree the answer 7 factorial, and that is 5,040. 3.2. If the 3 silver cars must be parked next to each other, determine in how many different ways the cars can be parked. Now, it looks like this. There's one big group for your 3 silver cars, and then there's 1, 2, 3, 4 cars left. And then your answer is 3 factorial, this is for the 3 silver cars, times 5 factorial. Why 5? There's 1, 2, 3, 4 cars left, but then this group where you find the silver cars, they have to form part of this other group. Therefore, there's 3 factorial times 5 factorial, and your answer 720. Question 4. The letters L, M, N, O, P, Q, 6 of them, are randomly arranged in a straight line. 4.1. How many different arrangements can be created? Now, first of all, do you agree there's 6 letters, therefore 6 factorial, and the answer 720. Question 2. What is the probability that the letters L and M are not next to each other? So we will start by working out what is the probability that the letters L and M are next to each other. And that will be 2 factorial times 5 factorial. So the 2 factorial is for L and M. And then in fact there were 6 letters. L and M is out, therefore there's 4 left. But then L and M, they form their own little group. Therefore it's times 5 factorial divided by the total 6 factorial. Therefore, we find the probability that the letters L and M are next to each other is a third. But the question wants to know what is the probability that they are not next to each other. Therefore, the probability that L and M are not next to each other is 1 minus a third, and your answer 2/3. Before we continue, have you subscribed yet? And you can also visit my website onlinemaths.co.za. Also feel free to leave a comment or like my video. Let's continue with the examples. Question 5. Philip's boat has 3 seats on it as shown. 1. How many different ways can Philip, Harry and Sipho sit in the seats? Do you agree? The answer 3 factorial, and that is 6. Number 2. Calculate the number of ways that the 3 friends can be seated such that Philip and Sipho are seated next to each other. The answer 2 factorial times 2 factorial. Now just be careful. The first 2 factorial, this is for Philip and Sipho. They form a little group. And then Harry is left, but with Harry, there can be Harry first and then Philip and Sipho, or Philip and Sipho and then Harry. So you also need a 2 factorial for that arrangement. And then your answer 4. Question 3. The name of the boat is Hammerhead. In how many unique ways can the letters from the word be arranged? Now, first of all, do you agree when we count all the letters in the word hammerhead, there's 10. So therefore, it's 10 factorial. But now there's repetition. Let's look at this one. Do you agree? H, there's 2 of them. So we divide under the line with 2 factorial. For A, there's also 2 of them. So that's that factorial. The M, there's 2 of them. And the E, there's also 2 of them. So it's the total 10 factorial divided by 2 factorial times 2 factorial times 2 factorial times 2 factorial, and your answer 226,800. Another topic where you can score easy marks in paper 1 is the calculus basics topic. Click on the video in the left hand corner to take you straight to the playlist Calculus Basics.